Hi guys, this is Dr. Manjunath Channapgod from Anveshana Academy, Bangalore, India. Dear students, in the previous class we discussed about what is thermodynamics, application of thermodynamics, what is open system, what is closed system and what is isolated system. And also we discussed about examples for the open system, closed system and isolated system, and what all the different types of engineering applications we are having for different systems. That also we have discussed in the previous class in detail. Dear students, today in today's class I am going to discuss new topic, that is control volume. Okay, so today we will discuss about control volume. This is one of the topic in the basic engineering thermodynamics. Okay, so now dear students, control volume. To understand this control volume, I will try to take some live examples. Then I will try to convey the definition of this control volume. Okay, so now first what I will do, I will take one example that in saloon you can see there is a water spray bottle is there. They're using that water spray bottle. Dear students, if I want to calculate how much amount of water they are going to spray on our head, okay, the amount of water how much they are spraying on our head, if I want to calculate, then how to calculate that now? So that means how much amount of water, the quantity in terms of mass, how much water they are spraying. If I want to calculate, then how to calculate? So to calculate that, there should be a volume. With help of then what I will do, in front of this bottle there is a nozzle. That nozzle having a volume. That volume we will call it as control volume. With the help of that control volume, we can calculate how much amount of mass they are spraying. This is one example, dear students. What is control volume? Yeah, what is the exact definition of control volume? I will try to explain you in detail in upcoming slides. Okay, so now just I'm showing some engineering applications or day-to-day applications what we're having. Just have a look, then I will try to convey you the actual definition of the control volume. This is one application, dear students. Second one, you can take mehendi. When we are going to apply mehendi, right, here is the mehendi we can take. When we are going to apply mehendi, right, so then what will happen? We are going to apply this mehendi on hand, right? Then how much quantity, that means what, how much mass of mehendi we are going to apply on the hand. If I asked you how we are going to calculate that, we require one volume. That volume we can call it some control volume, dear students. What is that control volume? Then you can see here now in front of this mehendi pocket there is a nozzle. You can see this nozzle having a volume. Now it is having a surface. What I will do, I am going to put in a surface here. Now when I am going to join all this surface, we are going to get a definite volume. That volume we can call it as a control volume. That control volume will help us to calculate the mass of the mehendi what we are going to apply in our hand. Dear students, just here to understand the control volume, just I am taking some live examples which are related to mass calculations. Okay, mass flow rate calculations. When it comes to control volume will help us to calculate both energy as well as the mass across the system boundary. That you have to keep it in your mind, dear students. These are two applications where we are going to calculate the mass. Example, just to understand the control volume, I am giving such kind of live examples. Okay, now I will move towards third application, that is water shower. Okay, then here now you can see here in this application, but in the both first and second application, you can see how much amount of mass can be transferred, can be calculated with the help of control volume, as I told. But when it comes to third applications, here now water is falling, right? That hot water, you can call it as a hot water. Okay, hot water is falling. Now if I want to calculate how much amount of water is falling down, okay, or how much amount of water is getting sprayed, that I can calculate with the help of a volume. So that volume is nothing but what, control volume. What I will do, dear students, I am going to assume a volume. That volume is nothing but what, just what I will do, I will put a line here, the surface, I will put a surface here. Now then it completes, it's become what, a volume or a definite volume. We can say that definite volume is nothing but what, control volume. With the help of the definite volume or control volume, what I can do, I can calculate how much amount of water is getting sprayed. One thing, with the help of this control volume, I can also calculate how much amount of heat is getting transferred. That is Q. That is about what? Heat energy. Without this control volume, it's very difficult for me to calculate how much amount of mass is getting transferred as well as how much amount of heat is getting transferred. Okay. To calculate this both mass and energy, what I can do? I can use this control volume. One application, that is third application, dear students. Okay. Now we can take a fourth application, that is what? Heat exchanger. So now fluid is getting entered here now. Okay. Hot fluid is, you can take a cold fluid. With the help of this hot fluid, that fluid is, cold fluid is getting heated. That assume that hot fluid is coming out here now. When the hot fluid is right, so now what I will do? I will draw a line here now. I will draw a line here now. Then this whole volume, whatever the heat exchanger having volume, right? It is going to have certain quantity of matter, or it is going to have a fixed region in a space. That fixed region in the space means what, dear students? You can take whole whiteboard, right? You can take whole whiteboard. In this whole whiteboard, what I am doing here now, I am going to have a fixed region or a definite volume for study or analysis. What I'm doing, what type of analysis I'm going to do here now? When it comes to heat exchanger, right? How much amount of hot water, you can take it hot water here now. How much amount of hot water is getting out? That is nothing but what? M is equal to how much? Then how much amount of heat is getting out? That also I can calculate with help of what? With help of a fixed volume or a control volume. That is known to be what? That is nothing but what? Control volume. Dear student, simple example you can take. When you are going to play a kabaddi, right? What you will do? In a whole ground, assume that 1 kilometer radius or 0.5 kilometer of radius ground. What you will do? When it comes to play kabaddi game, right? What you will do? We are going to put a line, right? That means what? In that line, we are going to consider number of mass. You can players per study. What type of study? The performance we are going to check there. Which team is what team having more performance, like that. If I want to do analysis, if I want to do study, what I'm going to do, I'm going to have a definite volume or a fixed region. That fixed region or definite volume we can call it as a control volume, dear students. That is what? Fourth applications. Like that, n number of applications you can see. When it comes to now fifth application, exhaust. When it comes to scooter, right, or scooter or bike you can take, right? When the exhaust is coming out, right, exhaust gas, easy, exhaust gas is coming out, right? How much amount of mass is getting out? Okay, how much amount of heat is getting out? That I can calculate with help of a volume. That volume we can call it as a control volume. What is control volume here now, dear students? The control volume is a volume, okay, where definite volume is considered in a volume is considered for the analysis of the heat as well as heat energy as well as the mass. Okay, that is nothing but what? Control volume. You can see this is a fifth application. Next, you can take one more application. You can take, dear students, when it comes to in your a vehicle or tailoring shop or in your garage, you can see lubricant bottle they are using, right? The lubricating, they are going to apply lubricant on the you can take a chain, cycle chain or bike chain or whatever it may be. When they are using this kind of nozzle, right, at the top, at the front, you can see it looks like a nozzle, right? It looks like a nozzle. Now, so if I want to calculate how much quantity of lubricant they are applying, that is M, I can calculate. Assume that if it is a hot lubricant, assume, but it is not a hot lubricant, just for understanding, assume that how much it is a hot lubricant, that how much amount of heat is entering, how much amount of heat is getting exit, that is Q2. That I can calculate with the help of what? This nozzle. What I am going to do here, I am going to put in a volume here now. That means what? Certain quantity of matter I consider or a definite volume I consider to do the analysis of mass transfer as well as energy transfer. That volume we can call it as a control volume. This is 6 examples you can see, dear students. You can see when it comes to your home, right, you are using in a water bottle, okay, to clean TV or laptop or something else, right? You are going to spray, right? You are going to spray water or some cleaning liquids. Then if you want to calculate how much amount of water you are spraying, that I can calculate. Assume that this at the front you can see there is a nozzle. Then what I will do, I am going to draw a line here. Then the surface it is having a fixed volume as a fixed surface. Then I am going to join here. Then it becomes what? It looks like a nozzle, dear students, again. Okay, then it becomes what, when you're going to join all these lines, right, you are going to get a volume. That volume is nothing but what, definite volume you are going to get. That definite volume is nothing but what, control volume, dear students. Okay, so like that you can take a perfume bottle also. When we are going to spray the, right, as perfume, that bottle act as what, one of the application of what, control volume. Like that you can take pesticides. When we are going to spray pesticides, right, that pesticides we can take, or fertilizer we can take there, what we are going to do, how much amount you are going to transfer, that also we can calculate with the help of a volume. That volume we can call it as a control volume. Dear students, not only these applications, you can see here now in your heart, right, when it comes to your heart, right, the blood is entering and somewhere it is going to end. Then what I'm going to do here now, I'm going to put a line here, I'm going to put a line here now. Then whatever the total volume we are going to consider for the study, when it comes to control volume will help us to calculate how much amount of energy is getting transferred, how much amount of mass is getting transferred with the help of the volume. That volume we can call it some control volume, dear students. This is one examples you can take. One more you can take, when you are breathing, right, air will enters and it will exit. When you are exhaling, right, the hot air is coming out. Thus how much amount of air is coming out, then we are going to put a volume here, right, then it becomes what, complete volume. That volume or a region in a space, what I've done, I consider to study them, how much amount of mass is getting transferred, how much amount of heat is getting transferred. That is nothing but what, control volume. These all are applications of what, control volume, or examples for control volume we can say, dear students. Now this just I given you the examples to understand the control volume. Here without control volume I can't do any kind of analysis. That is known to be control volume. So okay, dear students, now I will move towards the exact definition of control volume. Now what is control volume? In thermodynamics, control volume is a fixed region in a space chosen for the analysis of mass and energy transfer. Often it is referred as a open system. Okay, what is open system, dear students? Now we already know. Then I will draw a line. Certain quantity of matter is there. That matter is surrounded by a volume. That volume is nothing but what, control volume. That means what, it's a definite volume. In a whole board you can take whole board. What I have done, I have taken only small region in a whole space. The small region which is having in a volume, that volume you can call it as a definite volume. The fixed region or a definite volume which is considered for the analysis of mass and energy transfer, that is known to be control volume, or we can call it as a open system, dear students. One definition. One more definition, you can see one thing. Fine, one more definition. It refers, what is control volume? Control volume, it refers to a definite volume on which attention is focused for a energy analysis. What is that? You can see now. So what I have done here, you can see whole board. You can see whole board. In this whole board, what I have done, I have taken only small region in a whole space. For what? For analysis of what? Energy transfer and mass transfer. That is known to be control volume. Then that control volume going to have a boundary. That boundary we can call this a system boundary. That control volume or a fixed quantity of matter or a region in a whole space which is considered for the analysis of the mass and energy transfer. That is known to be control volume. And that volume is surrounded by a surface. That surface we can call it as a control surface. Okay, control surface. Then you can see here now, dear students, as I told, this control volume is nothing but what? Open system. How it is open system? Dear students, assume that there is a container. What I am doing here now, assume that hot air I am going to supply and taking out. Assume that. Then that whatever the quantity of matter you are going to consider, right? That means what? In the whole board again, I am going to take a small container. In that container, I am going to store a hot gases. Okay, that hot gases will come out and will go out. Assume. Then what happens now? Both mass is also getting entering into the system and going out of the system. But whatever the volume we are going to fix, right? With the help of that volume, what I can do here now? That volume we are going to put a surface. Then it becomes a small region or a region in a space. That space fixed region or a definite volume which is considered for the study of the mass as well as energy transfer. That volume we can call it as a control volume. How it is, dear students? One example I will show you now. Now assume that there is a nozzle, dear students. I will take this example, nozzle. Okay. Now the steam is getting enter into the system and it is going out. Okay. Now once the steam is getting enter, right, hot steam. When it comes to steam, it is obviously it is a hot. When it is getting enter, right. So now assume that this dotted line is the what control surface. Dear students, assume that if there is control, there is no control system, then what will happen? The steam is getting enter and it is exiting here now. Okay. But with the help of this steam enter and exit, is it possible for me to calculate the how much amount of heat is getting transferred here now? Okay, how much amount of that heat transfer is represented by what Q? That is it possible for me to calculate the Q without this control surface? No. If there is no control surface, there is no control volume. If there is no control volume, we cannot calculate the heat transfer. Not only heat transfer, we cannot calculate the mass transfer also. What I will do here now in the nozzle, what I am going to do, I am going to draw a line. Then I will join here now. There is a fixed boundary and it's an imaginary boundary. Then join all the lines. Then we are going to get a volume. That volume we can call it as a definite volume or a fixed volume. That means what? I am going to consider a definite volume for the analysis of mass and heat transfer. That volume we can call it as a control volume. What is control volume? Control volume is nothing but what? Definite volume, which is way on which we are going to do some analysis. What type of analysis? We are going to calculate the mass as well as the energy. That is nothing but what? Control volume. Okay, fine, dear students. Now, with the help of this control volume, what I can do? I can calculate mass flow. That means what? How much amount of mass is entered. That is M1. M1 dot also you can take. How much amount of mass is getting transferred? Xg. That I can calculate with the help of this control volume. What is that control volume? That you can DS on dotted line is there, right? Here one side it is imaginary, as I told. Here it is a real boundary. Then we are going to join, right, all the lines. Then we are going to get a volume. That volume is nothing but what? Control volume. With the help of that control volume, what I can do here now? I can calculate the mass flow rate. That means what? How much amount of mass entered, steam entered. How much amount of mass exited? The mass of the steam. That I can calculate, one thing. And also I can calculate with the help of this control volume, I can calculate how much amount of heat is transferred or entered into the system. One thing. And how much amount of how much amount of heat is transferred from the system or out of the system. That I can calculate. That is nothing but what? Energy in and energy out. One thing, energy may be heat energy or it may be kinetic energy also. You can take kinetic energy. Inlet, kinetic energy, exit. When it comes to heat transfer, that I can take it into the thermodynamics. When it comes to energy analysis, I can take kinetic energy entry, kinetic energy exit. When it comes to thermodynamics, I can take with help of then how much amount of heat is entered, how much amount of heat is exited. That I can calculate. But this control volume is not only restricted to only heat transfer or thermodynamics concepts, but it's also applicable for what? Fluid mechanics. When it comes to fluid, right, the steam is also one kind of fluid, right? Then how much amount, what is the pressure of the steam before entering the control or before entering the nozzle? Then what is the velocity of the fluid before entering into the nozzle? And what is the velocity of the fluid when it is coming out of the nozzle? What is the pressure of the steam when it is coming out of the nozzle? These all things I can calculate with the help of a volume or a volume. That volume we can call it as a control volume, dear students. That control volume may be fixed or it may be moving. Why so? Because the boundary may move. If the boundary started to move, the control volume will move. Okay, that volume, that means what? Control volume is a volume where fixed or definite volume is considered for the study of mass and heat interaction. That is known to be control volume. Okay, with the help of this control volume, what we are doing, dear students? We are doing another energy analysis, we are doing mass flow, rate calculations, we are going to calculate heat transfer, that too in thermodynamics, and also we are going to calculate pressure and velocity of the fluid in fluid mechanics. Okay, so the application of this control volume is too vast. Okay, how it is that we can see here now. Now, real world applications, because it, as I told, control volume has many applications. How it is? Human lung, one application you can see. Okay, so before going to human lung, okay, how much amount of air entered and exit, that also I can calculate with help of volume. Jet engine, what is the thrust, that I can calculate. How much amount of fuel is consumed, that also I can calculate with help of volume. That volume is nothing but control volume. Pump, then how much power is required to run the pump. Okay, what is the pressure of the what is the pressure of the fluid which is coming out of the pump, that also I can calculate it with help of a volume. That volume you can call it as a control volume, dear students. Like that you can take heat exchanger, like that you can take a water faucet, like that you can take a river dam. So these are all applications. When it comes to river, right, if I want to calculate the forces acting on the dam, what is the energy is getting, how much amount of energy is getting dissipate, that also I can calculate it with help of a volume. That volume we can call it as a control volume, dear students. Okay, so these applications, just I will show some animation and I will try to explain you, dear students. So now when it comes to tap, you can see, right, the flow rate is coming, right, this water is coming, right. Then what I will do, I'm going to put on a volume here. Now that volume will help us to calculate mass flow rate, as well as even when it comes to water, right, pressure also I can calculate, velocity also I can calculate. That control volume, that means what, the control volume is a volume in which what we are going fixed region we are going to consider. Okay, and that fixed region is surrounded by a boundary. Across this boundary both mass and energy they are going to interact. That volume which is considered for the study, that we can call it as a control volume. What is it, control volume? You can see now what are the important key points of this control volume. It is having a fixed volume, that whatever the volume it is having, right, that is fixed. Then mass transfer, both mass as well as energy can transfer across the system boundary, and it is going to have a surface, because to accumulate the fixed quantity of matter or a region where we should have a surface, that surface we can call it as a control surface. Then if you were started to calculate the area of that control surface, right, then that area we can calculate surface area, control surface area we can say. Like that, these are some important key points we have to remember for the control volume, dear students. Now as I told, I will try to show you, now I will show some application of the control volume, that you can see here, dear students. One by one you can see here now. So now here nozzle, right, so the spray bottle you can take. Okay, spray bottle, as I told, in a cutting shop, right, if I want to calculate the how much amount of water he is spraying, that I can calculate itself of what, control volume. What I will do now, I will put in a line here, then here also one line is there, here also one line is there, then I'm going to get a fixed volume or a definite volume. That definite volume or fixed volume is nothing but what, control volume. With help of that control volume I can calculate the mass flow rate. One thing, not only mass flow rate, I can calculate the velocity of the fluid also. One thing, both entry and exit, one application you can see, dear students. Similarly you can see second application, water dam. As I told, water dam, right, what I can do now, the forces acting on the dam, at what velocity the fluid is coming out of, that I can calculate with help of a volume. That volume we can call it as a control volume. Okay, then pump, dear students. Now next applications you can see, that is pump actually. Okay, so pump, the water is flowing, right. Now what I will do, I will put a line here, boundary here, then it is a fixed boundary, then here also I'm going to put a boundary, then here also I'm going to put a boundary. Now it becomes what, control surface. That control surface, inside that control surface there is a fixed or definite volume. That definite volume is nothing but what, control volume. With the help of that control volume I can calculate the mass flow rate or discharge we can say. I can calculate the velocity of the fluid which is coming out of the pump. One applications you can see. Now dam also can see here now, dear students. Okay, the pesticide sprayers also you can see. Okay, fertilizers, liquid fertilizer sprayer application also you can see, dear students. Okay, so now these all are applications of what? Control volume. Okay, so if you want to list the more application of this control volume, that we can see here now. Nozzle you can see. Nozzle means what, dear students? This is what nozzle. Okay, so now what I've done, when we're going to draw this line and this line, right, we're going to get a volume, definite volume or fixed volume. That is nothing but what? Control volume. With help of the control volume, I can calculate velocity, pressure, drop, heat transfer, mass transfer, everything I can calculate. When it comes to diffuser, it's a opposite to the nozzle. Here nozzle is used to increase the kinetic energy, whereas diffuser is the to decrease the kinetic energy and to increase the potential energy. Turbines we can see, compressor we can see, heat exchangers, desuperheaters, throttling valve, internal combustion. In these all applications we can see the control volume. How it is, that you can see here, dear students. Okay, control volume. Control volume is volume in fixed volume or a definite volume which is used for the analysis of energy and mass transfer. Okay, so now you can take a compressor. Okay, that I have shown it here now. Then you can take a pump. Then you can take a battery. Now how it is battery? You can see now. This is going to have a definite volume. Definite volume or control. The definite volume is nothing but control volume. Okay, so you can take a pump. Okay, you can take a car radiator. How it is car radiator, dear students? You can see now. The hot water is getting entered, right? Hot water is entered, right? Then what I will do now? Entered, I will draw a line. Okay, then I will draw a line. Then it becomes what? Total volume. Okay, what I'm doing now, whatever the volume it is there in the radiator, right, that I will consider it as a definite volume or a fixed volume. So that definite volume or a fixed volume will help me to calculate the mass or heat transfer or velocity or pressure drop or any other parameter. That volume we can call it as a control volume, dear students. Like that you can take a solar aerator, water heater you can take, steam turbine you can take. Okay, as I told, that volume may be variable. That variable means what? It is a movable. Okay, so now that means what? You can take a small quantity. You can example to understand this control volume. We can take a cube. In that cube you taken a certain quantity of matter. That hot gases itself you can take. Then what happens? The hot gases is going to come out, right? That means what? Heat. Mass also, assume that a small opening is there, mass also is coming out. But you should have a fixed volume. That fixed volume or a definite volume is nothing but what? Control volume. Then that volume we are going to have with the help of an area. That area we can call it the control surface area, a surface area. Okay, so this is what control volume, dear students. If you want to list some applications of control volume, you can see, you can list, dear students. Okay, turbines, internal combustion engines, diffusers, nozzle, compressor, heat exchangers. These all are the applications. Dear students, I hope you understood what is control volume and you understood the application of control volume. Dear students, hope you understood the concept of control volume. Herewith I request you please subscribe my channel, do comment and support. Thank you.